Okay, my little cloud is starting to come together. I have one server that's dedicated to DNS and some other networking tasks. In my last video, I set up a server for shared services that'll be used by my Proxmox cluster. Today I'm going to create my first shared service called a container registry. So what's the purpose of a container registry and why do I need it in my little cloud? You see, all my applications will be running on top of Kubernetes, which sits on top of Proxmox. Let's zoom into Kubernetes and take a closer look. Applications in Kubernetes run in something called a pod. The pod contains your application code, which runs inside containers like Docker. What the pod gives us is a lifecycle for creating the containers and tearing them down. During the creation process, the pod will grab the container image, and that image has to come from somewhere. And that somewhere is called a container registry. A container registry is a repository that catalogs and stores container images. Some popular registries are Docker Hub and Red Hat's Quay.io. But for my cloud, I'll create my own so I can keep everything in-house. The software I decided to use for my container registry is called Twuni. I'll have a link to the GitHub page in the description below. Before the install, there are a few things I'll need. First is a way to authenticate to the service. And for that, I'll use a simple username and password. Those credentials will be encoded using a tool from the HTTP Apache project. Again, the Twuni service will be installed in my shared services cluster on top of Kubernetes. I'll use a tool called Helm to handle that. Finally, I'll be securing the service using a TLS connection. If you want to learn more about how I created the certificates, check out my videos explaining TLS. Okay, from this point on, I'll be typing in some commands into a shell. To make things easier, I've created a GitHub page with all the steps. Link in the description below. I'll also assume that you have a Kubernetes cluster running and it's ready to go. To authenticate to our registry, we'll need an encoded username and password. I'll first need to install some tools from Apache, and then run this command to perform the encoding. And this is what the encoding will look like. With that in place, I need to create a Kubernetes secret for my TLS certificate and private key. I'll use these kubectl commands to create the namespace and the secret. The important part here are these two files, the certificate containing the public key and the private key. Make sure the files are located in the same directory where you're running the command. Here's another command to inspect the secret that we just created. With the dependencies out of the way, I can now run Helm to get everything installed. Helm uses a values file, and this is just a YAML file with configurations for the installation. Let's take a closer look at the one I'll be using. At the top, there's some information about the Docker image and the version of Twuni that I'll be using. This will be pulled from the public Docker Hub repository. Further down is an ingress section. This defines how the registry will be exposed outside of Kubernetes. I'll be using a domain name called registry.heavymetalcloud.lan, and I'll be securing that domain with TLS. The secret here contains the public and private key that I set up earlier. Further down, we have a persistent section. In my last video about shared services, I talked about persistent storage in Kubernetes. I'll be using the Longhorn storage class that I set up in the previous video. Basically, the Docker images have to be stored somewhere, so I'll be storing them as files in the Longhorn storage system. Finally, there's a secret section. The important entry here is HT_password. This is where you pass the encoded username and password from a previous step. Alright, there's one more section I want to show you. Under the config data block, you have the option to add a proxy. This will allow you to mirror public container registries and effectively act as a pass-through with some caching. In this case, I'm mirroring a Docker repo. Okay, with the values file configured, let's run the Helm command. To make sure that worked, I'll run a few kubectl commands, and here you can see the pod that was created, and this is what's actually running the container registry. This command shows the ingress along with the connection information. From a storage perspective, these are the Kubernetes objects that will handle persistence. The higher level abstraction is called a PVC, and the low-level storage is a PV, or persistent volume. Now let's make sure everything is working. I'll hop on my laptop, then grab an Nginx image from a public Docker Hub repository. To access my Twuni service, I'll first have to log in. Then I'll tag the Nginx image so that it points to my registry and then push it up. To test, we can use an endpoint that Twuni exposes as a web page. If everything is working, we should be able to see the Nginx image from the browser. And there it is. Alright, my first shared service is installed and ready to go. In my next video, I'll install the next service called OpenLDAP that I'll use to manage user accounts in my cloud. Thanks for stopping by, and I'll see you in the next video.